Picture this, you're playing a game of tag, you're running around trying to avoid getting tagged. But then, out of nowhere, someone you don't even see tags you. That's kind of what it's like when HIV enters the body. It's sneaky, and can catch you off guard. HIV is a virus, and like all viruses, it needs to get inside a living cell to survive and multiply. Think of a virus like a little pirate ship looking for an island to dock at. HIV is most commonly transmitted through certain body fluids like blood, semen, vaginal fluids, or breast milk. These fluids can carry the virus, and if they come into contact with a mucous membrane or a cut, HIV can slip right in. It's like finding a secret passageway into a castle. Once inside, HIV begins its mission to take over your body's defense system. HIV is particularly interested in a type of white blood cell called a CD4 T cell. These cells are like the generals of your immune system leading the fight against infections, but HIV is a master of disguise. It attaches itself to the surface of the CD4 T cell and tricks it into letting the virus inside. Once inside, HIV can start making copies of itself. Think of it like this. HIV sneaks into the castle, your body, finds the general's headquarters, CD4 T cells, and then takes over the castle from the inside. It's a sneaky strategy, but understanding how it works is the first step in fighting back. Remember those CD4 T cells, the generals of your immune system? Well, HIV has them in its crosshairs. These cells are incredibly important because they help your body fight off infections. They're like the quarterbacks of the immune system, calling the plays and making sure everything runs smoothly. But HIV is a virus, and viruses need to get inside living cells to make more copies of themselves. Think of it like this. A virus is like a set of instructions, and it needs a cell to read those instructions and build more viruses. HIV is particularly good at getting inside CD4 T cells and hijacking their machinery. Once inside a CD4 T cell, HIV releases its genetic material, which is like a blueprint for making more viruses. This blueprint gets inserted into the cell's own DNA, effectively turning the cell into a virus-making factory. The cell starts churning out copies of HIV, which then go on to infect even more CD4 T cells. It's like a hostile takeover. HIV uses the cell's own machinery against it, turning it into a tool for its own survival. This process of infection and replication is how HIV gradually weakens the immune system over time, but it's not a quick process, and that's where the concept of latency comes in. Imagine a ninja hiding in the shadows, waiting for the perfect moment to strike. That's kind of what HIV does during its latency phase. After infecting CD4 T cells and making copies of itself, HIV can actually go into hiding. It doesn't disappear completely, but it becomes very difficult to detect. During this phase, HIV inserts its genetic material into the DNA of the infected cell, and then it just sits there, silently waiting. The infected cell may look and act perfectly normal, but it's carrying the hidden instructions for making more HIV. This latency phase can last for years or even decades, and during this time, the person infected with HIV may not even know they have the virus. This hiding act is one of the reasons why HIV is so challenging to treat. It's like trying to find a needle in a haystack. The virus can lie dormant for years, quietly replicating and spreading without causing any noticeable symptoms. But even though it's hiding, HIV is still there, and it can reactivate at any time. Certain triggers like stress or illness can cause the virus to wake up and start replicating again. This is why regular HIV testing is so important, even if you feel healthy. Now imagine a football team where the players can't hear the quarterback calling the plays. Everything gets disorganized and the team can't function properly. That's kind of what happens to the immune system when HIV takes hold. As HIV replicates and destroys CD4 T cells, the immune system starts to weaken. Those CD4 T cells are vital for communication within the immune system. They send out signals that tell other immune cells what to do and where to go to fight off infections. But with fewer CD4 T cells, these signals get weaker and less frequent. It's like cutting the wires on a communication system. The different parts of the immune system can't talk to each other effectively, which makes it much harder for the body to fight off infections. The immune system becomes confused and disorganized, leaving the body vulnerable to a whole range of opportunistic infections. This weakened state is when a person with HIV is considered to have AIDS, or acquired immunodeficiency syndrome. AIDS is the most advanced stage of HIV infection, and it's characterized by a severely compromised immune system. People with AIDS are highly susceptible to infections and illnesses that wouldn't normally pose a threat to a healthy person. It's a serious condition, but thankfully, with modern medicine, it's no longer the death sentence it once was. We've made incredible strides in HIV treatment, and that's what we'll explore in the next section.